Welcome. We are so happy that you are here to help us celebrate BPS CTE, so Career and Technical Education Week. My name is Kelly Ann Mahoney. I am a youth program specialist at Autodesk, so I will be doing more formal introductions later. We're also joined by Mass Robotics. We are co-hosting this with the Boston Public Schools Office of Career and Technical Education. We also are going to meet a wonderful civil engineer later on today. So a lot going on, but we're going to begin. I know that if you're watching live, many of us just ate lunch. So we're going to do a little activity to kind of focus our brains and help us think about a design challenge that we're going to be launching today as well in celebration for CTE Week. So my friend Khalif Mitchell from Mass Robotics, who is the STEM lead over there, who is also going to be presenting with us today, is going to help us with this warm-up activity. So I'm going to ask Khalif. Khalif, you want to say hi first?
Yeah, hi, I'm Khalif. She introduced me already, but yeah, I work at Mass Robotics, and we work with startups and help them get their products from A to Series A. So very
Pretty
excited
cool.
to be here.
We're excited that you're here, Khalif. So I'm going to ask Khalif. So you haven't seen these pictures yet before, so this is a surprise to you. So I'm going to ask you, who is this product or space designed for? In what problem might it be solving or addressing? So I'm going to show a series of pictures, but for each picture, you're going to think about these two questions. So if you're a student who's watching live, you might be like jotting down some ideas as Khalif is guessing and thinking about it too. So let's get started. So again, the questions, Khalif, are who is this product or space designed for? And what problem might it be solving or addressing? Are you ready, Khalif?
I guess so.
All right. So the first image, what are you thinking?
Okay. It's got an ice rink, so it's got to be some kind of community-based something. I would guess families. It looks like there's some kind of apartments or something going on, and it looks like a centralized area. So I guess it's trying to get people outside and talking to each other.
Mm-hmm.
Yeah, that's my best guess.
And what do you think? So what's a problem that you think that they're trying to address? So you think like getting people together?
Yeah, definitely. It very much seems like this is a centralized area, so they want people to kind of enjoy nature. I see they have the different areas. You have like the forest area, the lake area, the rink area. Yeah, that's my best guess.
Very good at observing details, Khalif. We'll find out later. What about this one?
Uh wow. What is it made out of? Stone, resin, something? Uh wow. I have no idea even how large this is.
These are all good questions you're asking, Khalif, though, and trying to figure out, what the purpose is of something. You might think about the materials. You don't have a sense of the scale right now. So this could be like super huge, right?
Yeah. When I first look at it, what I think about are these really artsy phones people make, because I see like the little things that look like buttons at the top, but it doesn't strike me as electronic.
Mm-hmm.
Um,
Could be some type of a wearable device, maybe.
yeah. The thing that it looks most like is a Fitbit.
Mm-hmm.
It looks a bit like a Fitbit. So possibly something in the same space. One of the health monitors, something like that.
Mm-hmm.
But yeah, I'm still a little bit at a loss. That one's
Mm-hmm. It's a tricky one. We'll move on to the next one, and maybe we'll find out later.
okay.
What do you think this is?
Wow. Well, I see the factory in the background, some
Mm-hmm.
kind of cold environment. I don't. It could possibly be maybe if you're in an area where they have a lot of factories, trying to bring in some of that forested area or some kind of walkway.
Mm-hmm.
As there's the ramp going up, trees. It still has some kind of chimney stack there, so it could be hiding a factory. This
Mm-hmm.
could just be hiding a factory so that it looks nicer and doesn't have that kind of abrasive look. I know if you go through New Jersey, they have a lot of manufacturing, but you go through the highway and it's just factories, all you can see.
Mm-hmm.
And it can be a little bit jarring.
Hmm.
Um,
I wonder if that little circle at the top, the ring of smoke, is symbolic in any way. Perhaps we'll find out later. What about this one, Khalif?
Looks like a photo
Mm,
or a painting.
mhm.
Um, am I?
So you're
Is it
thinking about,
clothing?
yeah, I think it's the garment that we're focused on. So thinking about who is it designed for, which has kind of given us some indication, at least in the imagery. Could be more than just that person, though. So who is it designed for, and what problem do you think it might be addressing?
I'm still at a loss. I mean, it's
Mhm,
clothing, designed for women, I'd assume.
mhm,
Um, though that's not necessarily the case.
mhm.
Uh, it's definitely bright, so uh, it could be bright clothing that shows in the dark.
Mm,
Those are the two cues I have here.
mhm.
Um,
Those are good guesses for now.
yeah.
Let's move on to the next image. What about this one?
Okay. This I see a little bit more of. I'm gonna do a fairly wide, like complete guess. A lot of an issue we have in a lot of cities is water goes over pavement like crazy. It creates a big hazard for heavy rainfall. It creates a lot of flooding. Trees do the opposite of that. They suck the water up, and this looks like some way to bring the water into a gutter system. And it looks like they made it kind of a public area. So it's like it's fun for you see the kids splashing in the water, but that's getting funneled right towards the trees they have in the area.
Wow.
So
Well,
that it's just a natural process.
your brain is working really hard on this, Khalif, so I'm going to give you a break on the next one, although it is an interesting
That
pattern.
looks like farmland.
Yeah, I think it's, yes, I shall not give away what it is because there is a resource that we're actually going to be sharing later that teachers can use and also um, students can access and read as they're working on their design project. But these were all, so I'm not going to give them all away now. You can read about it, but these were all um, designs that were meant to address issues of environmental sustainability and to help communities in thinking about that. And I believe this is out of Denmark as well in Europe. So these are all kind of Northern European solutions to problems. And why we're talking about that is we are going to be launching as part of CTE week in the Boston Public Schools, we're going to be launching a design challenge called Make It Green. And in the Make It Green challenge, middle school students are being encouraged to use design as a way to solve a problem related to environmental justice or issues of climate change. And this is all part of Career and Technical Education Week. This webinar is presented by Autodesk. So I work for Autodesk. I'm a youth program specialist there. I'm also going to be talking to you about a tool that you might use in the challenge called Tinkercad, which is part of the Autodesk family of tools. I just wanted to thank Mass Robotics and Khalif for joining us today as part of this webinar. And also we are going to have Nikki, who is a civil engineer, who actually has her own educational nonprofit called Albadas. So she'll be joining us later on as well. But before we get started with the formal program, I also want to introduce Dr. Jennifer Smith, who is the Assistant Director of CTE for the Boston Public Schools. And she's going to talk to us a little bit about what career and technical education means and what it means for Boston Public Schools students. Jennifer, I don't know if you're on mute right now.
Sorry about that. Yes.
No worries.
Trying to be silent. But I was just welcoming everyone and thanking you for the intro. Welcome to Boston Public Schools celebration of Career and Technical Education Week. I'm Jen Smith, the Assistant Director for CTE, as we call it in the city of Boston for Boston Public Schools. I want to thank all of you for joining, and hopefully you'll get a lot out of this webinar. And a special thank you to Kellyanne Mahoney from Autodesk and for putting this unique challenge together for us and having special guests with us as well today. But before we begin the challenge and talk about what that means, I want to just tell you a little bit about what career and technical education is. Your middle school students, in the next few years, you'll be thinking about moving on to high school. So it's really important to know which high school is right for you and what some of the career options you're thinking of. So CTE Pathways are offered at the high school level, as I mentioned, and they prepare students for college and career opportunities throughout the 4 years that you're in high school. It provides hands-on learning, embedded academics and knowledge, problem-solving skills and team building, employment and internship and co-op experiences as well. Upon graduation, students will not only earn their high school diploma, but also industry recognized credentials. So these are all great things to have on your resume, whether you're going into the career field, apprenticeship, or you're going on to a 2 or 4 year college. In addition to Madison Park Technical Vocational High School, which a lot of you are familiar with, the English High School and Boston Arts Academy are also well known for their CTE pathways in the district. But we also have 8 other high schools that offer one or more CTE pathways. So I just want to give you a quick glimpse of what they look like. And this video will show us a few of the programs that we currently offer at Madison Park Vocational Technical High School.
At Madison Park Technical Vocational High School, we prepare our students for Boston's most in-demand careers in fields such as healthcare, construction, technology. Madison Park students are primed to be the drivers of Boston's future economic development.
What I enjoy most about Madison Park is the dual enrollment plan, where I get to graduate with a 2-year college degree and also my cosmetology license.
With access to training experiences and college level courses, Madison Park students are able to create their own path. Students who wouldn't automatically go to college directly after high school are set up for success in industry because now they're able to make industry-leading wages, benefits, and retirement security.
I'm proud to be a student at Madison Park where I can get a certification in welding,
Dental assistant,
culinary arts,
electricity,
metal fabrication,
cosmetology, graphics communication,
carpentry,
nursing, STEM programs, and much more.
Madison Park allowed me to pursue my passion in culinary arts.
I plan on graduating Madison Park with my cosmetology license to start a career.
Madison Park students achieve real-world, authentic, and marketable skills. Students, regardless of what program or study that you choose, something outstanding is going to happen for you.
So those are just a few of the programs that we offer at Madison Park. This slide shows you the 20 programs that we currently offer at Madison Park High School. I think it's important to know that in your freshman year, you do almost a complete year of exploring all of these programs and deciding what your skill sets are and your thoughts are about what you like to do, and slowly help you to make that decision as to which program you want to spend the next 3 years in at Madison. We also have other programs in other high schools, and I want to just highlight a few. Boston Arts Academy, one of our newer programs that was just approved from the state, is Fashion and Technology. We're the only one in the district, which is pretty cool. Boston Green Academy is also a new program. Environmental Science and Technology is what they offer there. Boston International Newcomers Academy offers medical assisting, which is a wonderful program. Lots of summer internship opportunities and healthcare positions. And one of our other newer programs is biotechnology, and we have piloted that at 2 schools, East Boston High School and also New Mission High School. So as you can see, there's quite a few offerings. I believe we're up to about 45 programs, but we are always looking to expand opportunities for our students in the city. And it's more important for you to know about them so you can make a better choice for yourself when you're looking into all the high schools opportunities. And my email address is at the beginning of this slideshow. So if you have any questions or comments or need some help with any of this, please contact me directly. I'd be happy to help.
Thank you so much, Dr. Jen. In looking at all of these options, having been a Boston Public Schools graduate, I wish that there are such clear connections between what I was learning in school and future careers that I could have. So that's what we're actually trying to do for you right now through this design challenge for middle school. So we want to see all of your creative ideas to think about how you could use them to address a real world problem. So this is the design prompt, which is to create a model that shows how you would address an issue of environmental justice or a problem related to climate change. We're asking you to explain how your designs solve this problem through images, through words. Numbers are also part of a model. I'm going to show you Tinkercad as a way that you could create a 3D digital model, or of course you could create a physical model. We're going to get more towards the end of the webinar talking about some of the rules and the due dates and all that stuff having to do with the contest. But for now, we just wanted you to think about, what are some skills that you can gain through this challenge, and how can you show them off through this challenge as well, and be really proud of your work and the idea that you come up with to help solve this problem. So one way that you might demonstrate your skills is through technical skills. So Tinkercad, which I'm going to be demonstrating for you shortly, is one way that you can demonstrate these skills. Innovation. So we want to see your most creative ideas. We want you to really think outside of the box. We want you to, to come up with new solutions to problems that we never realized that, we as adults sometimes are not as innovative in our thinking as kids are. So really want to see your most creative ideas. We want you to know through your work and through your whole design process that you are really thinking about how you can make an impact through your design. So how can you make a better world through your creativity and through your problem solving? And lastly, we want you to be able to practice your communication skills. So sometimes when we come up with a really innovative idea that no one's ever thought about before, it makes it really hard to actually communicate that idea. So there are some resources at the end that I'm going to show your teachers to help you think about ways that you can pitch your ideas, if almost like you were an entrepreneur on like Shark Tank or something like that. So really thinking about how you can sell your idea and inspire others about your idea. So what we're going to cover during this webinar is you're going to learn about a tool, which is Tinkercad, that you can use to create a design. We're also going to hear from Khalif from Mass Robotics about how you can make a better world through robotics. So even thinking about if robotics is something that you're interested in, how can you apply that interest to this challenge and imagine new ways to use robotics in order to address issues like climate change? And lastly, we're going to meet an engineer and find out how this challenge connects to their work. So Tinkercad is the tool that we're presenting to you today. Again, my name is Kellyanne Mahoney, and I'm a youth program specialist at Autodesk. So Autodesk makes software for people who make things. So people who build bridges, who build skyscrapers, who design smart cars, who design the graphics for video games and for movies. So we make all of those tools for design professionals and for construction professionals. However, we also have this tool called Tinkercad, which is free for everyone. All of our professional tool, or about 100 of our professional tools, are also free for students and teachers, but Tinkercad is free for everyone. It's a creativity tool. It's browser-based, so you can access it through your Chromebook if that's how you're working, particularly if you're distance learning right now, which I know a lot of us are. I know my daughter is. So it works very well in Chromebooks. Tinkercad also works on iPads. So I know some BPS students have iPads at home through like their school, through their learning program. So Tinkercad, actually, over the past couple of years, we've really improved the functionality of Tinkercad on iPads. And one of the really cool features, if you are using an iPad, is that you can unleash your designs into the world through augmented reality. So there is a feature within the iPad where it's like you can make a design and then even like bring your iPad outside and place your design in an environment, or even do it inside your home. So that's Tinkercad. Tinkercad, there are 3 environments. So there's the 3D editor, there's a circuits editor, and then there's also code blocks. So I'm going to show you a glimpse of each of them. So the first is a 3D editor, and this might be what you're most familiar with if you've used Tinkercad before. As you can see, you're just dragging and dropping shapes onto the work plane until ultimately you're able to take your idea from your mind into reality. So you could do that through 3D printing, or you could make a design that has value to you just digitally as well. So again, as you see, I'm combining shapes, then turning the shapes from solids into wholes, and then subtracting from them in order to make more complex shapes. So I'm going to give a slower demonstration in a moment. Within Tinkercad, there's also the circuits environment. So maybe you've done circuits at school before, but it's kind of hard right now in this distance learning environment. It's a great way to simulate circuits. You can even learn how to code in Arduino. And the best part about simulating in a circuits environment is if you burn out a part, you did it digitally and not in real life. So you're not breaking things and wasting money. Lastly, there's the code blocks environment. So if you've ever used Scratch before, for example, it's the same sort of blocks that one would use in Scratch, but the blocks, as you can see here, are doing different things. So you're really using your computational thinking to design something that is three-dimensional that you could maybe even 3D print if you wanted to, or you could make this fun, an animated GIF, for example, like you can see here with your design. I just want to say too, because I know this is middle school, if you are 13 or older, you might have an easier, more direct way into Tinkercad. If you are under 13, you must have an adult moderate your account. So I will share this slideshow with Jen so that she can share it out with teachers as well, because I do have instructions here for if you are a teacher of students who are under 13, how you can get them onto Tinkercad. And also for teachers, there are other features there that help you kind of organize your classrooms and kind of make managing teaching Tinkercad a lot easier. So my first example of Tinkercad is, this is actually kind of on the theme of thinking about using design to address climate change. This is an example called Abalone House, which is an example of architecture that was inspired by nature. So this was actually the shape of the building was inspired by an abalone. It was actually a clam shell. And when we think about biomimicry, it's design that is inspired by nature, but not just the beauty of nature, also even the engineering of nature as well. So for example, the abalone shell is quite beautiful, as we can see here, but it also has a quality about it that it is very light, but also strong at the same time. So this is an example of how I designed just a part of it in Tinkercad. So sometimes it's hard to make really organic shapes in Tinkercad. So I'm going to show you a strategy here for how I do that. So I'm using the scribble tool, and you can see in using the scribble tool in Tinkercad, you can actually sketch in 2D, and then you can bring your sketch into this 3D environment and continue to play with it. So you can see that I'm rotating it here, and then I hit Command D, which is duplicate, and I shrink it down a little bit, and I tip it a little bit with the to change the angle. And you can see really quickly, just hitting Command D, Command D, Command D over and over again, you can see how I quickly was able to make this really interesting shape that kind of looks like the abalone house. For teachers watching, there's also, and students, there's slower demonstrations of Tinkercad within the resources that we'll be sharing with you today. So I know this is going a little fast. I just want you to see what the capabilities are of using Tinkercad. So this is a shape that's a hole. So I'm dragging out a box, and then I am manipulating it to stretch it out to make it bigger. You can see I'm just pulling on the handles there, kind of similar to like if you were, editing a photo in Google Slides, for example. A lot of the commands are the same. So what then you see me doing there is I drew a box around it, and then I grouped the two shapes together in order to kind of shave the bottom off of that shape. I wanted to subtract it. So that's just one example. I wanted you to see some other examples. So this was one that I actually made for New Mission High School, which is doing a project on seawall design. So I found this really cool design for a seawall in Princeton, New Jersey that they're thinking about, which is a really cool example of a seawall, because it's not just addressing the issue of flooding. It also, sometimes when we build seawalls, they tend to obstruct the view of the sea. So this is a really innovative design, and that you can see that in sunny times, it's a way that it is protecting the people walking from the sun, and they can still see the ocean. But then when the waves come, it flips down, and then the waves come in and it blocks out the waves. This is just another example from Tinkercad, so you can see what code blocks is capable of. So as you can see here, this is a design for stairs in code blocks. So you can see the script for how to make the stairs here. So it looks very similar to Scratch. And in Scratch, you can also play with variables too. So we're going to talk about that. So you hit play at the top and run the code, and that's what it makes. So it makes that set of stairs that's designed there. So I'm hitting refresh because I want to show what happens when you play with the variables on this particular set of stairs. So you can see at the top, I'm going to go into the width of the stairs, and I'm going to change it from 18 to 40. And then I'm going to change the number of landings from 2, I think I changed it to 3. And then I'm going to run the code again and see what happens. So speeding it up and hitting play. And then you can see how quickly you can make these designs that then you can save your code, the script for the stairs, and then reuse it for different projects, which is a really cool way of thinking about design because it makes the design process really playful and very flexible as well. I also just lastly wanted to show you some examples from the Jackson Mann School. So they actually won the Make It Real contest last year for middle school. And they thought a lot of their students, even though we didn't ask them directly, a lot of them thought about ways that we could use robotics to address this challenge. So this is one student's design of a robot that swims and it cleans the ocean. And this is another design from a student who thought about one of the issues with solar power and solar gain. So being able to harness the power of the sun to create electricity is sometimes when birds poop on solar panels, which is an exciting topic for middle school, it makes it not be able to take in as much of the solar power if they get dirty. So this was a robot that was actually designed to clean the bird poop off of solar panels, which I thought was a really cool way of thinking about how to imagine designs using Tinkercad. Lastly, also, I just want to show you that I know I went really quickly with my demonstration, but here are some lessons in Tinkercad. If you go to the Learn page, there are 7 that once you master these 7 lessons, and they're very self-directed and you get a burst of confetti at the end to know that you did it correctly, you are ready to roll in Tinkercad. So it shows you how to place it, how to view it, how to move the shape that you put onto the work plane, how to rotate it, and each of them only take about 2 to 3 minutes to complete. So just 20 minutes and you will be ready to roll in Tinkercad. Also for teachers, this is a biomimicry lesson that I wrote for Tinkercad that if you want a really clear kind of written out plan for how to do this challenge with students, you could also use this biomimicry lesson because it does still ask students to use design to address the issue of climate change. So next, I'm so excited to introduce Khalif, who's going to talk a little bit about how you can make a better world through robotics. Khalif, take it away.
All right. So before I begin, I just wanted to give a quick rundown on what makes a robot. Sorry, next slide, please.
Sorry.
So really brief overview. A robot needs to have these 3 elements: a sensing element, a computing element, and an actuating element. The sensing element is just what the robot sees. These could be cameras. This could be infrared sensors. This can also be just feeling. If it doesn't actually have eyes, but it can feel its environment or sense temperature, that is how it detects the status and the changes of the world around it. The computing element is how it takes that sensor data and creates an action plan. It actually decides how it's going to use that data to do things. And the actuating is how it actually does the thing. It's how it moves, which is an essential element for a robotic system. These could be motors, servos, could be pumps, fans. As long as it's moving and changing and interacting with the environment around it, it's a robot. And so when we talk about the benefits and the advantages of robotics, next slide, please, we have to talk a bit about scale. And so I have right here a picture of Tesla's Gigafactory, which is where they make all their batteries for their solar roof systems for their cars. And it's about 30% complete right now. And you can see here this wonderful graph that shows the pyramids of Giza, the Burj Khalifa, and how big the Tesla Gigafactory will be when it's completed. It's going to be the largest structure on Earth, largest building on Earth. And the highlight there is it's almost completely autonomous. They have entire factory lines that are all robots. And when you're making something at that size and you're having it all automated, each robot in there really only does one thing. They do one thing really well, but combined with all these other robots that are working together, they're able to do something at absolutely massive scales. And so anytime we're talking about climate change and trying to do something big for the world, we have to be thinking about things at this scale. But at the same time, All it takes is one robot doing one really good thing. And when they're all working together, now you've actually made a big change. Second thing here is agriculture. Oh, my slide messed up. It's all good. But agriculture is one of those areas that we don't think about very often in our day-to-day, but actually is one of the biggest factors in how the world functions. So I have two visuals here. The bottom one shows how much space agriculture and pasture land for cows and such, how much land that takes. That is, if you see the yellow and the brown in that graph at the bottom, that's all over 50% of the land of the United States is pasture land and farmland. And in the top graph, we see fresh water withdrawal. So that's taking water from freshwater areas, lakes, rivers, ponds, and what that water is used for. And a lot of it's for thermoelectric power, for cooling power plants and such, and irrigation. We're right back to farms. And so when we're looking at climate change again, we have a problem with fresh water. We're consuming a lot of fresh water. We're not putting that all back in the system because these aren't all sustainable. And then we need to feed more and more people as time goes on. And we are defaulting to worse things that take up more land, more space, which we need for people as well. It's also reducing forested areas, wetland areas. These are huge issues. So robots are coming to the rescue in a couple different ways. One of the big ones is inspection. So we've seen, actually go back for a sec. We've seen a lot of boom in drone inspections, being able to survey very large swaths of area and looking at it with different sensors to figure out how we're going to. I'm going on and on. The drone here, it uses sensors to see which areas have been watered. And so we can more efficiently water based on the map it makes on the right. And then on the bottom, we have an example of a hydroponic farm. And hydroponic farms, instead of using whole bunches of land, they actually plant right in the water, and they could be made into these large towers. And many places are doing that completely autonomously. Next slide I'll talk about is the ocean. So we know the ocean has a lot of things we don't know about it, but one thing we do know is that we are absolutely destroying it. Very famously, there's the Great Pacific Garbage Patch. It's more than twice the size of Texas, and it's just floating out there. And there's more than one of these garbage patches, right? And so recently we've seen a lot of efforts into how are we actually going to clean up these oceans. So we talked a little about biomimicry. It was mentioned a couple times in this. And you can see right there, Silver 2 is just one robot that mimics a crab that goes along the seafloor looking for plastic. We see again on the right, the waste shark. It's just going along the top of the water and looking for trash and just skimming it out the water. The bottom two, Mr. Trash Wheel and Seabin Project, are actually not robots as it stands. Trash Wheel kind of stays right where it is, uses the water wheel to power itself while it's sorting through all the trash. And the Seabin Project is literally just a bin in the water that has a pump, and it skims trash from the top of the water. Those two things, however, are very close. They're missing just a couple elements to be more efficient and robotic at the same time. And then we see inspection drones as well. Inspection drones are going to be in almost every field that's covering large area. You're going to need drones to scan entire areas and see what's going on. Where is trash? What is the water quality? All these kind of things have been done very efficiently with the use of robotic drones. And on the last slide, I'm just going to mention there's so many more areas in this. We right now, waste processing, recycling plants, separating trash, robotic, wildfire prevention. We've seen a huge surge of wildfires in the past couple of years. California burned to the ground almost. Brazil's entire rainforests are just getting decimated. Australia was half fire for I think a month. It was crazy. And so that's a very dangerous place for humans to be. And so robots are combating that. There are also obvious areas where you can prevent this from even being an issue in the first place. And part of that goes back to some of the things we talked about with agriculture and how we actually use the space that we're given. But before I end, I just want to reiterate that when we're talking about robotics, it's important that you mention how does it see things? How does it sense the environment around it? And when you're doing your write-up, your presentation, and you're making your designs, it's very important to address exactly how it does that. And there are a lot of different sensors you can look up and have fun and see how exactly they process the world. How does the robot thinks, the computation element? That's just, what is it going to do with the sensor data? Is it going to relay it to another robot? Is it going to relay it to people? Or is it going to actually do something about it in the actuating area? Is it going to say, move towards an area that needs helping? Is it going to change its system so that it, sends something over to another area? Is it going to move faster depending on exterior motivators? As long as you think about these three elements and you're looking at things, think big, but one step at a time, and you can make something that's truly awesome with robots.
Thank you, Khalif. You certainly have us thinking big. And it doesn't surprise me that our students last year, particularly in middle school, found robotics as a source of inspiration and imagination based on what you were telling us. Even just thinking about like measuring and monitoring, like I even think of like coral reefs. I know that one of the issues in coral reef depletion is how hard it is to actually measure the damage. And you kind of wonder, like, how could robots be used in that circumstance? I know even in construction, and in thinking about like making construction process more affordable, robots are being used, in that same capacity of like measuring and monitoring. You probably
You're
know
right. I was about to say there's a lot of inspection robots for construction itself. Some of them are just, they make models based on the plans and can overlay that directly over the building, so you can know exactly where things should be without needing someone to go in and measure it another time. Also, 3D printing is robotic. Don't forget that. So anything you think about that's 3D printing, 3D printing with concrete, it's all robots.
And the other thing that made me think about is sometimes when we think about like robotics and the future of work, some people worry that like robots are taking our jobs. But from what you're saying today, it seems to me it's not necessarily that they're taking our jobs, but they're making jobs more safe. Like, for example, even like in a construction site, a lot of the things that make construction, for example, dangerous is because, of doing tasks that maybe a robot could actually do, and even better and more efficiently. But also that they're creating these like new interesting jobs. Like you could be like a drone pilot, for example, in the future, and you could also be helping the environment at the same time.
Being a drone pilot is a job right now. It's a license you can get once you turn 16.
Serious? I didn't know you could be 16 and be a drone pilot.
Yep.
Awesome.
It's actually not even that difficult. One thing I'll mention, you were talking about jobs. I brought up the Gigafactory for that reason as well. And when I'm talking about scale, the world of humans is getting bigger and smaller at the same time. And we continuously have to think about problems at a larger scale than we've ever had to before. And so robots allow us to do things at the scale necessary. At the Gigafactory, they automated a lot of things. Then they went back and said, you know what? Human needs to be here. There are so many elements that human will always do better, and that a robot is always going to do better. A robot can carry a couple tons of stuff through a factory way better than a human can. A human can do delicate work, very varied work, way better than a robot can. And honestly, better than it ever will be able to do. But when you're thinking about things at such a large scale, if you have robots deployed in the middle of the ocean 24/7, humans can't do that, right? And so it just allows us to enter these entire new areas of thought that we've never been able to do before.
And making jobs more accessible too for people like laborers with robotic exoskeletons. I could talk about robots forever, Khalif, but I guess we can. All right, so next we are going to ask an engineer. So we're going to hear from our friend Dr. Nikisa, or I call her Dr. Nikki Albors, who is a civil engineer in her background, but she's also the president and founder of a really cool educational nonprofit called Albadas. So we're really excited to have Nikki here today, Dr. Nikki, so that we can kind of put the design challenge into context and think about how it connects to careers. So I'm just going to switch to the next screen, Dr. Nikki. And then it would be great if you could introduce yourself and just talk about kind of what you're doing today, and also a little bit about what it was like growing up and what kind of led you into wanting to become an engineer when you were a kid?
Thank you. Well, first, thank you so much for having me on to talk to you about my experience. My name is Dr. Nikki Albors, and I'm a civil engineer with a focus on sustainability. I grew up in the United Arab Emirates. We had lots of development and construction and engineering, and it was a country that was really undergoing a lot of building as it was a developing country. My father was a civil engineer, and so I was very lucky to be around builders, designers of all kinds, and engineers of all disciplines. So I had a very early on interconnectivity and introduction to all of these different topics. And I always wondered, how do things stand up, or how do you build that, or what went behind making that object, whether it's a bridge, a building, a tunnel. So everything that I saw around me, I had this big curiosity of how did it work? Tell me why it's standing up. So there was a series of books called Tell Me Why books. And I remember hounding my parents to buy all of them. And there was a time where I had to save up to be able to buy all of them, because it was a pretty big collection of these Tell Me Why books, because I just had an interest in how things worked. And I thought it was super cool. And being around my father, it got me really interested in that side of engineering things and designing things and taking things apart. So that's how I kind of got into engineering. Albadas Inc. is a nonprofit I recently started with a colleague of mine, Professor Gautam Das, and he's also a civil engineer. And we were interested in finding novel ways of getting students excited about engineering topics that cover everything and that also focus on the arts, because engineering is not only the STEM topics, it's really STEAM topics covering the gamut of disciplines, because everything is connected. And in the same vein, everything is connected when it comes to sustainability and climate change, because we have impact on how much we're consuming, what we're building, what materials we're specifying. So everything that we do every day has an impact on our environment from a variety of angles. So that's why our basic interest was bringing all of these different topics and disciplines together so that students would be excited about solving these global challenges that we're facing as a globe, because everything we do here has an effect downstream somewhere else. So everything is connected and it's in everyone's backyard.
I love it when engineers are thinking about putting the A in STEAM. It's one of my favorite topics to think about, and think about how we can harness our creativity to make a better world. It's also interesting to think about, when you're a child, you're very inquisitive and always asking questions. It's such a revelation when you realize that everything is designed, and, really try to think about who the person was that made it and what were they thinking about and how did they make it work. So that's super interesting. One of my favorite books when I was little was called, it was Richard Scarry's What Do People Do All Day? It was just this illustrated book of all the different types of professions with these cool infographics and stuff. So my question is for you is, what do engineers do? Because oftentimes we think maybe they drive trains. So what do engineers do? And what types of engineers are there? And then if you could talk a little bit specifically about why civil engineering kind of sang to you as something that you would want to pursue as a career.
Sure, of course. So engineers do everything, right? Everything around you, as you mentioned, has been designed by somebody. And someone has had a hand, an engineer has had a hand in bringing it to life and allowing you to use it. So from your clothes to the train that you may have taken today, to the building that you're in, to the furniture that you're sitting on, to even the food that you're eating, everything that is around us has been designed by an engineer. There's so many different kinds of engineers. So some of the ones are civil engineer, mechanical, biomedical, biological. Then you have industrial engineers, you have nuclear engineers. There's just so many electromechanical engineers. So there's a variety of different engineering disciplines. But I think the most successful engineers are the ones who can also understand the interconnectivity of all the disciplines and are also willing to explore other disciplines aside from their own. So I fell into civil engineering simply because my father was a civil engineer. So that was like my first exposure. And I got super excited about that because it was really building the built environment around us. And I thought it was super cool that I could build an igloo or build a tree house or, build a roadway or a walkway. So I thought those things were like really cool things because they kind of allowed us to expand our horizons. But that's the same token for all other engineering disciplines as well, with all the technology that we're using today. So all of those different products and different methods of mobility are all tied to engineering. And also, I mean, even if we think about clean water, for example, clean water has changed the lives of so many people in the globe. And areas in the world that still don't have access to clean water have a lot of challenges, and they're very resource deficient, and it has a very direct impact on their lives. So to me, I felt that civil engineering, which covers the built environment with vertical, horizontal construction, as well as water, wastewater, was just a very interesting area of work because I had a direct impact on people's lives. I have a responsibility, social responsibility to what I'm doing. And so do other engineers in the different disciplines that they have. So many different types of engineering. And the best, I think, is, really exploring what every and each kind of engineer does. What does an electrical engineer do? What does a computer engineer do? Are they they're building the hardware. They are making sure that we have electricity, right? Because they're designing transformers and substations. The buildings that we're living in, these are all civil engineer, architecture, mechanical. So all the disciplines intersect to bring all of these projects to life where we are able to live the life that we live today with having access to all the resources that we do.
Like a really great point too about, that there are these different disciplines even within engineering, but then there's all this convergence that's happening across the disciplines as well.
Exactly.
And that's really important because we have such complex problems that we need to solve, and it really does require a lot of collaboration and diversity of perspectives in order to be able to solve those really tough challenges. My next question, that kind of you spoke about a little bit, but maybe you could speak a little bit more about it, which is, how are engineers making a better world through their work? And are there any specific examples you could tell us about, particularly around environmental sustainability?
Sure. So, wow, that's such a big question to answer. Engineers have a direct impact on people's lives. A very easy example is what I mentioned earlier, which was access to clean water or access to any kind of water. There are designs that are already implemented in West Africa around harvesting moisture so that you would have potable water. This is a very cool engineering challenge and solution to harvesting moisture so you would have drinking water. And typically, right, we don't really think of that as being something that we can do, but that was a collaboration between civil engineers, architects in terms of the shape of the structure, as well as biologists who came together to design this beautiful piece that really looks like a piece of art, but at the same time, it's harvesting moisture from the air. And now, the community members have potable water. So these are the kinds of really cool, innovative solutions by mimicking nature and understanding the nature around us that we can bring to the table as engineers and designers.
So this is another time that biomimicry has come up in our discussion today. So that's a really interesting concept to explore. My last question, this might not be too hard for you to do because I act like one. Imagine I'm a middle school student, Nikki, Dr. Nikki. If I were a middle school student, what should I be doing right now if I want to work in engineering in the future?
Oh, I'm just like you. I think I like to be all kinds of students, from kindergarten student to high school student. I think you should never, regardless of which level of schooling you are in right now, don't lose your inquisitive nature. Ask a lot of questions. Try and understand how things work. Take things apart. You have access to copious amounts of research, so definitely take advantage of that. I mean, I remember that when I was growing up, we didn't have like Google or any search engines or Google Scholar. I couldn't access a university's library online. I mean, these are all really great tools to start really looking at what's available to you from the end of the scholarly material. But from the other side of it, in terms of thinking about solving problems, let's just, think about the current situation we find ourselves in with COVID-19. So COVID-19 has brought a lot of challenges to the table, whether it's indoor air quality, access to clean surfaces, particulate matter, right, with our air. So all of those, the use of masks, disposable masks, and different disposable materials that now we have to think about how are we going to solve that problem, right? Because are they going to go to a landfill, or are we going to come up with some recycling solutions, or are we going to come up with different solutions where we don't have to throw them away? They don't have to be disposable. So there's so many things that you can observe around you and see where the problems are, or if you think you can do something better, you can come up with an idea that will be a better solution to the issues around us or to the way we're using things, right? An inventor also is someone who improves upon the design or a process and comes up with something new to solve that problem or to approach that problem. So as a middle school student, you can be inquisitive, observant of your environment around you, ask a lot of questions, reach out to people who are in the industry that interest you. You all should have access to LinkedIn, and create yourself an account on LinkedIn. Check out the companies that you find really interesting and cool and are solving the global challenges we're facing right now, and try and reach out to them and see if you can e-shadow what they're doing. So kind of like the book that you're reading about what folks are doing every day. You could also do something similar to try and understand, what does it mean to be this kind of engineer, or what does it mean to be working for this kind of company, working on a certain solution. So many things that you can take advantage of, but the first part is just being inquisitive will get you really far.
Well, Dr. Nikki, this is awesome advice for our students. You provided so much inspiration, and also just kind of keeping it relevant and talking about even the situation that we're in right now with the COVID pandemic. So really, we just want to thank you so much for helping us think through this design challenge and launch us into coming up with our own innovative ideas through being inquisitive and curious. So thank you
so much for inviting me. It was such a pleasure to talk to you about my experience. And if you need anything, I'm also here. You can reach out to me. More than willing to help. And good luck on the design challenge. Very exciting.
Thank you, Dr. Nikki. We might take you up on that offer. All right, so before we go, though, we just wanted to make the challenge really clear for you, for teachers to know that we're here to support you, and obviously students as well. So this challenge, the Make It Green challenge that we've been talking about, begins this week. So this is CTE week, and we are excited about it. So there are some deadlines. The one in March is really just meant to also help you along through the process. We wanted to extend this challenge, February, March into April, to give you enough time to really kind of work through it and really kind of feel the different phases of the design process. So around March 8th, we're going to be hosting a design critique, so that wherever you are in the process, maybe you're in a messy part of the process, and that's fine, you'll be able to share what you've done so far, so that others in the design community, people like Khalif and people, that we've met earlier in our other webinars, architects, might be able to give you some feedback on your work, so you can make it the best work that you possibly can to be proud of. So that finally, the April 2nd would be the final deadline for the contest. And we would be looking at all of the entries, and then the week before April vacation, we're hoping to have almost kind of like a Shark Tank, kind of more of like a formal pitch, where you would be judged on your designs and potentially to win prizes as well. So keep in touch with us. My email is at the bottom of the screen, so kellyann.mahoney@autodesk.com. If you want a copy of this presentation, I'm sure Khalif would be okay with us sharing his slides as well, right, Khalif? I'm sure.
Of course.
Cool. I wasn't sure if it was proprietary mass robotics information. And then also you can look at, so if you go to this URL at the bottom of the page, so it's Autodesk, so .sk at the end /CTE for green, you will be able to actually see kind of step-by-step instructions. They're written for a teacher. to be able to lead their students through the design process for this particular challenge. But I know that teachers have also pushed out a lot of these resources to students as well. So this is the same challenge that actually Jackson Mann did last year too, and did such a great job on. So that is the end of my formal presentation. I just want to say thank you to Khalif for filling my brain with robots for the rest of the day and all types of things, robots that I want to design or want someone else to design for me, like the snow shoveling robot. Khalif, hasn't happened
yet. It hasn't happened yet. You know, they're working on it. They're trying.
Okay. Dr. Jen, did you want to say anything before we sign off?
This has been really great. Thank you so much, Kellyanne, for putting this together. It was nice to meet you, Khalif, and I look forward to seeing the final recording that we can share with our teachers. And I really hope that we get some folks from the middle schools that join this challenge and learn a little bit more about career tech ed and all these great skills that they can do together as a team, the employability skills and the team building skills that we're looking for that will help them through their careers. So I thank you so much, both of you today. And thank you, everyone on the call.
Awesome. Thank you, Jen. So happy tinkering. We're going to sign off for now.